Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm here with special guest Liz Clark.
Hi.
And hello. And every week we're joined by Pedro, my brother, who's also at Adafruit. Hello.
Good morning, everyone. Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is the show where we combine 3D printing and DIY electronics to inspire you. I forgot the thing. Sorry. Hello, everybody. Welcome to the show. It is
last show of the year.
It's the last show of the year, December 17th, Wednesday, 2025. It's episode 509. And we have two new projects that we're going to take a look at. Pedro's got a new project that he released yesterday.
I think it's 3, isn't it? The e-ink one?
That's in development, but we'll talk about it. Liz Clark has accepted our request to join the show and talk about her festive project that we'll talk about. We have what else do we have? We have Timelapse Tuesday, and of course, we are hanging out in the Adafruit Discord server. So if you'd like to join us, you can go to discord.gg/Adafruit, and we're hanging out in the live broadcast chat channel where you can ask questions, make comments, post up GIFs, memes, all that and more. We're also streaming on all the normal networks: Facebook, LinkedIn, YouTube, Twitch, and X. So if you'd like to say anything there, we can bring in your chat. We like questions that we can answer. And we'll give shout outs to folks that are coming in. It's okay if you're not in live, because we know a lot of folks are out this week.
Or working.
Yeah. Hard to watch a podcast / live show when you're working.
I can't do it.
Can't do it. All right. Well, that's the show. Just kidding. All right, Pedro, we have, while you were making a second cup of coffee, we decided that you go first and then Liz, because she's the guest.
Yeah, totally.
Oh, yes, we have housekeeping stuff to do. Thank you so much, Liz. See, this is why I choose my co-host today, my special guest. Let's talk about the deals going on at adafruit.com/free. We have all the deals going on with starting at orders of $99 or more. They're going to get a free PCB coaster with a golden Adafruit logo.
Ooh.
For orders of $149 or more, they'll get the PCB Coaster Plus an Adafruit KB2040. That's that lovely dev board featuring the RP2040 chip, which also might be used in Liz's project.
It is.
At the top tier, if your order is $199 or more, you'll get the KB2040, the PCB Coaster, and free UPS ground shipping for continental US only. These get automatically added to your cart at the checkout, and while you're there, why not use our 10% off coupon code, good for the next 24 hours, Dreidels. Get you 10% off your order for everything that's in stock. The only thing it doesn't work on is, I believe, gift certificates.
Correct.
But all physical goods are good. So please use our coupon code. While we're talking about orders, Adafruit always does this every year. They have a special blog post dedicated to the shipping deadlines for this year. It's all broken down in domestic orders, international orders, and then all the different types of ground, USPS, UPS, DHL. So if you are still making orders, you want to get them in before the break. Those are the dates there.
Time is ticking.
The time has tuck. So there's Adabot. He will deliver your box.
Gets out of the truck, hobbles up to your house, drops a box.
In the snow.
You try to take Adabot, the resistor comes and is like,
Yeah.
Makes you resist and takes Adabot back.
I'm thinking of all those robots falling over in the snow trying to deliver.
Yeah, imagine
Cappy
in the driver's seat.
Yeah.
It's like, we got to go, matey. It's his time. Santos are waiting. That's the plot for the next Circuit Playground show. Adabot.
It's a special
job.
It's a fanfic of slow horses, but Adabot characters.
Right. And he's struggling because he needs a job and he has to make money because he's graduated.
All right.
Yeah.
Don't forget adafruit.com/distributors. If you're in
thank
a
you for that.
different country, you can get them locally. And
Yeah.
that's-
On the footer here, you can go to the distributors link. And if you are in any of these countries, provinces, you can see all the different places where you can purchase Adafruit stuff in your area.
Ooh.
All of these are great. Thank you, everybody, for
all over.
all over the place.
Global.
Romania, Sweden, Switzerland, Turkey, Ukraine, United Kingdom, and so
Canada.
on and so on. Mexico,
Mexico.
Costa Rica. So yeah, check it out if you are international. Which we all are. Okay. I think that's the housekeeping stuff. Anyone in Discord? Or is everybody still sleeping? Sorry, I keep going to the wrong thing. There we go.
That's right. It is Wednesday. I thought Monday was
Hi. Hello, Connor. Welcome to the show.
on.
We're gonna do our best to keep it on track here, but so far we're struggling a bit. Because
Yep.
we've all had too many eggnogs and chocolate chip cookies.
I've had too many
Right.
cups of coffee, and I think the sickness is coming. Hooray! Woo!
Not the sickness.
Mhm.
Well, on that
Surrounded by-
topic, we want to talk about fashion mixed with practical 3D printing. Pedro, you were asked to recreate a jewelry prop from a very well-known franchise called Star Trek. Tell us about.
specifically Star Trek Deep Space Nine, which I have seen even less of, so I had no idea these existed. We had to do
Well,
some
now
searching for these. PT requested some very stylish looking earpod holders. I swear every year we do an earpod holder. I think it was the elf ears last year.
Right.
He somehow came up on his feed. And I thought this would be a really cool way to try out some metal 3D printing. We're trying to do some tricks with the way we're grouping objects to have the metal printing be a little bit cheaper, but they caught on to us, so we're gonna have to do the order again. But you can print these in PLA on your own at home. It is a print to place chain that attaches to your earpod Pros. We got the little threaded connection here, so that if you have a different model of earpod, you can just update the diameter and switch these out. They press
Perfect.
fit. And then they have the little cutout for your touchpad thingy for your ears or your volume, and what is it, double press to skip track or whatever. Summon Siri to do whatever, translate, or what other features the earpods have. Oh, you can activate your camera now with them. Did you see that one?
I did not. That sounds cool.
Yeah, it was one of the updates for whatever iOS 26. Yeah, you can have it trigger your camera for recording. Maybe you can have Siri ask, set it up in accessibility or something. But either way, you have the ability to update the diameter of that, and then the threads will go along in the Fusion 360 sketch for that, as well as your ears. You're gonna have to measure your ears. These are sized to mine. PT had generated some really cool looking designs inside of whatever AI program he used to get some mock-ups up. I tried to copy those, like bringing it into Blender adding like some sculpt and stuff, but these are so thin and small that they did not resolve. So if you want to try and go ahead, like, I don't know, filling in this part right here and adding details, so you can definitely try have the Fusion file to bring into Blender, or try the sculpting environment inside of Fusion, try to add some more details to that. But again, this is size to my ear. All the different intricate designs that they were showing off, or that he generated with the AI, it fell off my ear. So that's funny. That's one thing AI doesn't know. Will this actually hold on to a human ear? Like it can't figure that out. So it's doing all these elaborate designs like at the top here, but you kind of really need this bottom part to actually, loop on to the back of your ear. So
I see.
Yeah, it's stuff. It's always funny stuff like that where you're like, oh yeah, AI can do this. No, I can't figure out human biology. So it can come up with a cool design, but the design won't resolve because of the size. Where am I? It's all these funny gotchas, from AI.
I think it's a clever solution to do kind of just like the thinnest kind of, shape, but also a printable shape with no supports. And also doesn't obstruct the ear canal where your ear would be.
For the chain links, you do need supports.
Oh, really? Okay.
Yeah, it's the tree support, so it's really easy to remove.
Okay. Yeah.
But that's what it looks like on both ears. And it works. Like if they fall off, you can move them around. Oh, where's my ear? There it is.
Yeah.
Fall off like that.
I mean, you wouldn't want to do that, but you guess you could.
Yeah, I mean, if you're running and whatnot. Yeah.
Well, I mean, if folks have like one of those ear things, the earrings that are like through the cartilage, is that what it is?
Oh, yeah. That is how it's pictured. It's probably just a clip on, though. I didn't want to go that route because it's like hook it onto my ear. Since I'm not used to having in ears anymore, it did hurt while filming. Like after I took them out, I was like, oh no, that's why I don't wear these anymore.
Yeah.
That works for your ear. There's chamfers and fillets all up in there, so it is comfortable. When I redo the metal order, we'll see which one comes out good. I have a different of the little clasp, the holder thing, to test the tolerance. So is it 0.2 or is it negative 0.2 for having the threads connect? So we'll figure that out. I don't know how long it's going to take for them to ship these out now. Since it's in China and it takes they usually fulfill the orders at night while you're sleeping. If there's any errors, you won't see it till the next day.
Yeah, what an interesting thing too, because it's metal. That makes sense to have something.
Yeah, I'm interested. There's two different types. Obviously, I'm not going with the titanium. I'm going with the stainless steel, and there's two different versions of that. One is labeled as lightweight, and then the other one doesn't mention that. So we'll see how the polish is and the weight differences are for that. And then again, the tolerances. They don't complain about the multiple holders being in one object.
Right.
So hopefully that's not the case. So super simple. You can 3D print these yourself. I didn't want to try the PLA metal since that tends to be a little bit more softer. With stuff like this, since the metal or the chain links are 3 millimeters thick. So, but if you're like polishing them, or as we've done in the past, putting them inside of a tumbler, I'm kind of scared that might break with the tumbling going on just to get that polish. So sure, I didn't want to go that route. Again, it was the whole thing of this that PT was suggesting was to test out the metal printing, see how that works for any future cases or projects. So super cool test case for that. I like the way that we're theming out a test.
Yeah.
So let's see. We have where is my guide for that?
Here, I got it for you.
Super quick guide if you want to grab the files for this. I was getting some errors doing uploading the media for this, but you can always get the link that I posted on there for the Fusion 360 file. So super simple. It basically is just a container for the files for this. Nice little synopsis here of the idea for it. And then if we jump into the 3D printing page, you can see the where to get the file for that. I'll let support know I can't upload that 3MF. So you are going to have to mirror the for the left and right, just because of the way that how you have going onto your ear. You need like a flat part of it, and I didn't want to model two different sizes for it. If you just mirror it on the X, and like I was saying before, you do need supports, and we're just using the standard tree supports for that. Bamboo Studio does a pretty good job of having the defaults come off pretty easy on that. And I did orient it so the bottom of the thread end and then the bottom of the main loop that attaches to the ear, they're all flat on the bed plate. So those should print first, and then the chains print in the air. I think what I should have done was like sort of adjusted the. Actually, no, that wouldn't work because of the type of the oval shape that I'm using for the chain. So never mind. Gonna have it where it's like where it's rotated 45 degrees. I've seen people angle that way.
That's how I thought it would be.
Yeah. Let's see, over to the assembly. Super simple. You just press fit, align the cutouts to the touchpad, and then attach your thread. Reminder that when you mirror the other holder, it is going to twist opposite to tighten.
Oh, it's funny. That's right.
So you'll have to twist it the other way. So that's funny.
Yeah.
And then the way they place on your ears, it's pretty simple. You just pull the top of your ear over it, and it will pull through. Here's what it looks like. And as the image, like we were saying, it's flat on the bottom of the thread part here to this piece here. Super simple.
Very nice.
Part. If you want to break that apart and have a different one for, I know the other pair of AirPods I have is the whatever the version 1 is it, and those the stem for that is definitely smaller.
Mm-hmm.
And that is pretty much it. Nice little way to test out doing some metal 3D printing. We'll show off the results, I guess, next year. See how that turns out.
All right.
And are these a change you forged in life?
What's that?
Are these a change you forged in life? Like Christmas Carol?
Oh, no. I mean, I can't wear these. They hurt my ears.
Okay.
Liz was making a joke reference to A Christmas Carol by Charles Dickens.
Oh.
Yeah. He's like, oh, whoops. Sorry, I missed that. All right, let's see if we have any questions in the comments.
Hooray. Yay.
Hello. Just some nice general comments. Your product design skills are always fascinating. Thank you. It looks like jewelry almost. It's a really cool design. Thank you, Hot Plastic.
Yes.
Yeah.
Yeah, PT's really into the gothy looking, fashionable, tech oriented design.
There's one question here, a little off topic, but still on topic for 3D printing. Is there a plastic we could 3D print LED light bulbs surrounds with? It depends. Yeah, if it's an LED, normally it doesn't get hot. So I think PLA is okay.
You know who had a video on that was, is it Make Anything? Devin?
Yeah.
He did a video where he made these like PLA shrouds so that he could have different colors
that's right,
over
yeah.
his light bulbs.
Mm-hmm.
So I would check that out.
Yeah, Make Anything on YouTube.
Yeah.
And also Hot Plastic has a good solution. PETG transition works well for Timelapse.
Mm.
That's very good. Very
That's
good.
what this bulb is right here.
Yeah. Oh, good. Oh, all right. We'll talk about that in the time-lapse segment.
I should have done a contour to make it even more transparent, but I didn't think of that.
What do you mean? Oh, like the vase?
Yeah, the vase mode.
Yeah, spiral vase.
I just printed it whatever the user had it set up the 3MF.
Yeah. Is it just one perimeter thick?
I think it's 2.
Oh.
Yeah.
Yeah. Yeah. Normally, vase only works when it's like a solid model that's not shelled.
Yeah.
So, all right, we're a little overhead. So,
3D printing.
okay. So that's Pedro's project. Very cool. Very cool. I'm sure PT is very happy. And then, so Liz, you wanted to create this thing here.
Yes.
What do we call it?
I wanted to create this thing. So ever since we got the silent stepper motor drivers into the shop, I've wanted to do some sort of spinning prop, maybe with like a holiday theme. Because you see a lot of those like in stores, and then even like Lego sets, a lot of them will have the automata kind of thing where it's just you're just trying to rotate one position and it gets movement. So I liked the idea of doing a planetary gear, which is when you have a center gear that's kind of like the sun, and then you have other gears going around it, which you can think of as planets. So then you get two motions, right? You get the outer guys rotating around, but then they're also spinning themselves. So I started by modeling up a planetary gear system by following a YouTube video in Fusion. And originally I was thinking about a Halloween prop, but you always run out of time. So then I was thinking about, winter holiday projects, Christmas, Hanukkah, and I thought Dreidels. So that brought us to this project here. So we have the planetary gear, and underneath is a stepper motor. And with a silent stepper driver, we're doing the ST Spin 220. And then everything is powered with this 12-volt power supply here. I'm able to use a buck converter so that we can power both the motor at 12 volts and then also give 5 volts to the KB2040, which is running CircuitPython code to control stepper motor. So if I power it up, you'll see it start to spin. And you got spinning dreidels. And since we're on 3D Hangouts, you can see that we've got multicolor printing on the little dreidels and then also the bigger dreidel that's the enclosure. And so I was able to do that with the Bamboo Studio lets you click and paint your models. And I did upload the 3MF files to the guide. So if you want to do that, you can. But even if you don't do the multicolor, I modeled the letters with chamfer around, which is 45-degree angle. So that means they can print really nicely. You don't get like drag or anything in the walls. So even if you wanted to just do one color and maybe paint them after, you can do that. So yeah, maybe we want to look at the guide. Or,
I want to talk a little bit.
You want to talk more? Okay.
A little bit more. Yeah. Let's see. What were some of the challenges you came up with?
Yeah.
What was the biggest challenge, I guess, with this project? Because I've done a couple gears, and for me, the biggest problem is just getting the tolerances right on the first go.
Yeah.
It tends to not happen. So.
Yeah. So there, the video I watched, and I should link it in the guide. Is it talked about the math you do to figure out the tooth size and how they're going to mesh and everything. And then I did add motion in the Fusion file to like confirm that things were kind of meshing correctly and stuff. But when I first printed the planet gears, I had a lot thicker. They were kind of the same thickness as the sun gear, which as you can see is pretty tall. And when I first tried to run it, it was, basically not moving. And I also start off with, we have a smaller stepper motor in the shop because I kind of wanted this to be compact, and it did not have the torque to be able to drive it. So I had to then switch gears to a larger stepper. And that also meant, now it's not using 5 volts for the stepper, so we have to think about how to bring in 12 volts. So that was definitely a challenge. But what I ended up doing was, I shrunk these down. So I made them a little thinner. I also did an offset. I think I did like a 0.15 offset just to make it a little smaller. And then I added a fillet, which is just a curve around the whole top and bottom. So that made it just a little bit smoother. And then that was able to solve it. And then as you can see, I can kind of pick up the gears really easily because they're sitting on this carrier plate.
Yes, let's see that.
And the carrier plate is actually what is spinning. And then these are sitting on top and are, you know, meshing and spinning from that. And I can actually just power it just to show that motion. And trying to making sure that I had it so that the offset things could fit easily so that you weren't getting any friction and stuff. That was definitely kind of the key to making sure we got like a smooth motion and everything like that. So
Yeah,
that was definitely challenging.
what's interesting to me is that there are no ball bearings in this at all.
Yeah.
You don't need the ball bearings for this because there's not a lot of weight. There's not a lot of force being applied to all the parts. So it really is like just having enough clearance between all the surfaces that are going to mate so that it's got a nice and loose thing. And for, you know, disassembly, it's great that you just pop off the gears. And
Yes.
like, hey, there you go.
Yeah. And the dreidels pop on too.
Yeah. So what's great is there's no glue for
Yeah.
anything.
Yep.
No glue needed. So they just kind of all
Yeah.
sit on top of each other, and everything has enough clearances to have a nice smooth rotation.
Yeah.
That's
Beautiful.
cool. Yeah. Yeah. Let's see, what else was I gonna announce?
Another thing was because I had this gear system first, and then I was adding the dreidels to it, and then adding electronics. I was trying to figure out how to make the actual enclosure interesting.
Yeah.
So at first I just had this like cylinder, and I thought it looked really ugly in the render. Like I remember finishing up the mounting plates and everything at the end of the day, and I just was staring at my screen, and I said to you, I was like, I don't like this. So I thought about it, and then I was thinking about tapers, maybe tapering it, because there aren't a lot of electronics in here. I have this plate to hide it, but that was the other part of it, is like there's not a lot, but because of the size of the gears and everything, it becomes this like big kind of object.
You're modeling around the stepper motor, the NEMA 17, which is like 30 millimeters tall, 20 millimeters on the X and Y. So working around that is like, well, what can I do interesting? And because the gear, you're kind of working around, well, it has to be a circle,
also
right?
That
Surely
too.
It has to be a circle, but it doesn't. You really came up with a good, clever solution.
Thanks.
It's a dreidel within
it's
a dreidel.
With a dreidel.
Yeah, so that's
perfect. So I do have the characters in the right positions around there. And when I came up with that, I was like, okay, I like how this looks. And then the way I did the bottom is it has just a little cutout so that it can just pop in and seat nicely there. And then I just have the DC jack in the back for power, and I made Shin a little smaller to accommodate.
Oh, that's funny. Yeah.
Yeah. But yeah, that was another like kind of design problem that I had at first of like of just an aesthetic issue of like, I don't like how this looks.
Yeah. You know, it seems so obvious now that it's all put together. Like, oh, of course it's a dreidel. The base is a dreidel, but in the time, like I had no idea that it would be a dreidel.
Yeah.
Yeah. I did contribute one thing. I did the I've always done a bunch of mounts. For stepper mode, so I was able to send you a model of the mount, so you don't have to worry about that. Prints without any supports, and it's got this kind of weird shape. But
that, and also the mounts for the stepper motor driver, the buck converter, and the KB2040, because I'm actually using basically the same circuit that we used for the turntable design. And by using that circuit, it means you don't have to have a power supply for the motor and a power supply for the microcontroller, which is often something you can sometimes run into where you're like giving USB power, but then you need like 12 volts for another component. So the buck converter lets you give it, I think it's 21 volts to 6 volts, and it'll convert it down to 5 volts. And then the KB2040, which is also one of the freebies that we talked about, it has this raw pin. And what's great about that is you can just feed it 5 volts and it will power the board. So you just share ground and then you're all set, and it keeps powering it really simple.
Beautiful.
Yep. So I think those are the main things I want to talk about. Some challenges on the design front, but also the electronics. Real quick, we'll look at the the various stepper motors that we have. So this is the one that you started off with. It makes sense because like, oh, surely I'm pushing plastic. It's not heavy.
And when I first print, because you print one part at a time. When I started just with the actual like kind of, I've been calling it the gear carrier. This part. Oh yeah.
Here. Oops. The gear
this
carrier.
Part here. You test to make sure it's going to fit nicely on the shaft of the motor. And it did, and it was spinning great. I was like, okay. And then you add, the sun gear, that's spinning great. Okay. Then you add the planet gear and it's struggling, and then you put it inside the outer gear and it's not moving at all. And so then it's like, oh no, what have I done?
Yeah.
So, and you try different things, try more current, try, changing the micro steps with the driver, and then I had to kind of be like, okay, I have to go to a bigger stepper motor, and that also means I have to redesign the enclosure as well.
Yeah.
So
there is something here in the spec sheet, but like, how do you quantify that in your model, right? Like you really can't. You have to just try it out.
Yeah. Well, I mean, I think if you are a mechanical engineer who's thinking about torque and stuff like that all the time, you probably would, maybe look at that immediately and be like, oh no, that's not good. But that's not my background.
Right. Well, also Fusion doesn't really do that.
I was going to say, yeah, the weight isn't real until you actually print it.
Yeah. You'll tell it what the material is and be okay, this is metal and these are the interacting forces, and it'll give you a rough estimate of what the torque is going to be. But for us, we're just gonna hey, we're just gonna try it out. So this did not work.
No.
5 volts, not enough. Sorry.
Not enough.
So this is the most common one that you see. In 3D printers and whatnot. These are standard run of the mill NEMA 17. And
now that we have the silent stepper motor drivers, you don't often, if you're just using kind of just a standard driver, you get this like coil whine from stepper motors, which is really annoying.
Yeah.
So with the silent stepper drivers, and why I started thinking about props like this when they came into stock, is now you're running it and you're not hearing that whine. So it would be like if you're running like a low powered servo where you don't really hear it. Same now with the steppers, which is really nice.
Yeah.
I remember the original one that Lamar sent. It was singing the Dreidel song with that noise, the frequency.
You can't do that now with steppers. You need an 8-bit.
But on top of that, if you were to do that, it would make it wouldn't be a consistent movement. So I think it would make the gear mechanism look really jerky. So that was another reason why I didn't end up having the stepper sing.
Another thing I'm realizing is you can see here in the photo, we have the motor feather wing, which we didn't want to use that because then your motor's really loud.
Yes.
Because it's using I don't even think it's using a stepper driver. It's just like an H bridge thing.
Yeah, the H bridge, that's
which is like loud.
Very loud.
Yeah. Yep. So motors. Motors. All right. So learn.adafruit.com. You'll see it's in the new Learn Guide section.
Yeah.
Overview page just covers all of the things. Here's a good look at the circuit in all its glory, minus the stepper motor.
Yeah, and we do have a fritzing diagram too that shows how to do all the wiring. But yeah, we've got the buck converter on the far left there, and then the ST Spin 220 silent stepper motor driver there, and then the KB2040 all the way on the right.
Did you have to tweak the limit here?
I kept it at about 12 o'clock, which is half an amp, because this one has 0 to 1 amps.
Right. Okay.
So
cool. All right. We'll talk more about that as we get into it. All right. As far as parts go, I think everything is in stock, which is nice.
Yeah.
Except the power switch.
Yeah,
you can find that.
Yeah, you don't necessarily need the 5 amp one anyway. Either. I prefer that one because then I know I have enough.
You'd love overhead. Yeah. Very good. Some wires and some screws. All right.
So we have our circuit diagram. So all those pins on the ST Spin are going just in pin order on the KB2040 with just general GPIO. And that allows the CircuitPython helper library to control the micro stepping, everything like that. The buck converter, it's taking in 12 volts and then it's outputting 5, which then goes into the raw and the KB2040 as we talked about. And then we're just going directly from the 12 volts into the ST spin for the terminal block for the stepper motor. So that's a nice trick if you find yourself needing 2 different types of power for a project. We also have a buck converter that converts down to 3 volts too, if you have something that needs 3-volt output. So.
All right. And everything is broken out here too?
Yep. I always try to use different colored wires too in the fritzing, so that it's a little visually easier to see. Yep.
Very good. Okay. On to the CAD files.
Yeah. So I have a list out of all the parts that you need and what ones you need multiples of. I've got the STL files and then the 3MF files, which the 3MF files are going to have the print orientation and also the color information too, if you want to do that. And then I also have the Fusion 360 project file and the step file if you want to remix it, because my other thought was when I modeled up these gears and it's the peg for the dreidel, if you wanted to have a different object on the gear, you could totally do that. Like, let's say you wanted it to be Halloween and you wanted like a little Frankenstein guy dancing around a fire. You could model up Frankenstein, you could pop him on the gear, and then you're good there. Yeah.
Yep. This is a nice GIF. It reminded me of using adaptive layers. You ended up using adaptive layers,
yes,
which is a thing you haven't really done yet. So
no, and I have to say there is some docs from Bamboo on how it works, and I read through the docs. I still don't quite understand what parameters you're adjusting, but it's basically a little check off, and it makes it so that if you have kind of these sharp contour, it will adjust how it's doing the layers so that it comes out a little bit smoother. And I turned it on just to try to get some cleaner lines on the bottom. Came out pretty good. I added some supports just to be on the safe side, just because also it's a multicolor print and you don't want to like waste all that filament and have it come out looking kind of bad. So
yeah, I've yet to really need it, but basically it's like instead of just having your whole model being 0.2 layer height always or 0.1 layer height, it mixes it, and it looks at the polygon count or what are the mesh, and it's like, hey, this one is going to have a lot of steps, so we're going to add more layers here, and it just does that automatically. It's using whatever.
And there's like a slider you adjust that's like smoothness versus like I think support or something like that. And so you're kind of fine tuning it until you think it looks like it's going to suit the model.
Yeah. So it's a good model for adaptive layer. Layer height. Good. Okay. That's 3D printing.
And then it is running CircuitPython. So you'll install CircuitPython on KB2040, which is an RP2040 chip. So you put it into bootloader mode and you can drag and drop the UF2.
Yep.
And then the actual code is pretty simple. There is an ST Spin 220 helper library, and what that means is you can just pass all the pins to the helper, and then the way that this driver works is you're toggling different combinations of pins high and low to put it into different modes. And for this, it's your micro step count, your speed, and so the helper takes care of that for you, so you're not having to change the values of a bunch of pins and like follow along with them. I think on the actual pinout page for the breakout, I have listed out like the different combos you need to do. So the helper just does that for you, which is nice. So this is basically just the example code that I have for the library, just set to 128 microsteps. I thought that looked the smoothest with this. And then in the loop, it's just constantly spinning. So it just will spin on until it's turned off.
Have you tested like the fastest speed where like the dreidels are like?
I have, and it's like upsetting. So
okay.
Yeah, it's a little too much.
I kind of missed it. You're right behind me now.
Yeah.
Been like,
it also makes it a lot louder too, because it's like jerky. So
melts the teeth. The gear.
Yeah.
Good.
Yeah. So I just wanted it to be like really quiet, serene. You know?
Yeah. So the motor doesn't make any noise, but it still has like this nice little like
Yeah,
a
it
low
has some
purr,
clatter with
a little
the plastic.
purring kind of
Yeah.
sound because the gear's got to touch something.
Mm-hmm.
Cool. All right. So you broke down the code a little bit here. You got your pins. You got your initializer.
Then you set your steps. I mean, you can do micro steps from, I think it's a full step to 250 micro steps.
Wow.
Yeah. So
You got even slower, huh?
yes. Yeah, you could.
Cool. All right. There's the codes. You can download the project bundle, which will have the one library.
Yes.
But that's probably all you need.
Yeah.
Okay.
That's it. So wiring, this was slightly advanced just because we are using the buck, so you have to think about like where your powers are going. But I have photos showing kind of the process I followed. You know, you have your DC jack, and I ended up using a JST PH plug, and that makes it so that the circuit isn't then trapped in the enclosure. So the DC jack has one end, and you could remove that if you wanted to, and then the main circuit's going to just plug in nicely. So the other end of the JST jack is plugging in, is soldered into the buck converter. And then we have a wire going from there for the motor. And that's how the motor is able to get the 12 volts. And then we're sharing grounds. I made sure to use heat shrink just to cover the solder joints. So you don't have any accidental shorts, especially because everything is getting put inside basically a blank box. So you want to make sure stuff's nice and stable. And then the 5-volt output goes to the raw pin on the KB2040. And we're sharing grounds and between the ST spin and the KB2040. And then the ST spin, even though it's getting the 12-volt power for the motor, that is not powering the actual IC on the board. That still needs 3-volt logic to the VDD pin. And because the KB2040 uses 3-volt logic, that's why you would then use 3-volt logic for the breakout. And then the GPIO, I just went in order. So the first pin on the breakout direction, and then to D2 on the KB2040, and then just count it up to kind of keep it easy to manage. And then that's all the wiring.
Very nice.
Yeah.
Nice.
Obviously, you want to keep the wiring lengths at a, nice medium where it's not too long.
Yeah, I kind of used the mount for the stepper motor as my guide of like
that's a good rule of thumb
of how long I wanted them to be. So long enough that they can make it, but not too long that they're going to get jammed by mistake or anything like that.
Okay. Onward.
And the assembly looks intimidating, but I tried to keep it kind of straightforward. So first, you're going to put everything into the mounts, and then you're going to connect the 12-volt power to the ST spin in the terminal block. And then next up, you connect the stepper motor to the terminal block on the breakout. And I always find it a little annoying or confusing to figure out the coil thing. So I tried to make sure to call that out. Of course, your stepper motor wire colors may vary. So my rule of thumb is also never just trust the wire colors. They can change, and also depending where you get your motor. So you may want to trial and error there. And then you put the mounts over the stepper motor, and then the electronics mount goes on top of that. So it makes this kind of little sandwich. And then you secure the cover disc over that, and those screws go through all those mounting holes into the stepper motor.
Okay.
And that's how that's all kept together.
Nice.
And then right at this point in the assembly is a good time to upload CircuitPython to the KB2040, test the code, make sure your motor is spinning, because after that, everything's going to be kind of enclosed a bit. You'll be able to get to it, of course, but you want to check that before you get too much further into the assembly. And then next up is the power. So the DC jack gets mounted into the back of the enclosure. And then you can put the bottom lid onto the enclosure, and there's a little channel that the main enclosure sits in.
Okay.
And then you're going to plug the DC jack JST connector into the other end of the connector that's on the buck converter. And then the stepper motor mount has screw holes on the bottom that line up with the bottom lid. And that's how it all gets sandwiched in. You just 4 M3 screws, and it will thread into the mount, and that will secure everything in. And then you put the gear carrier on top of the stepper motor shaft. That fits pretty securely because it needs to, that's what's actually spinning.
Yeah.
And then the planet gears go on the outer mounts, and then the center gear goes in there, and then the dreidels on the planets, and that's all set.
Yeah. Very nice. And then what's dreidel?
Just a quick use page just to let folks know what you do is you plug in your power supply, and then you should see the gears start to spin. We like to add a little explanation page to the guides just so folks know exactly the next steps to get going. And one thing you kind of pointed out to me when you were looking at it on my desk was that because the gear carrier is raised a bit, it does kind of look like the gears are kind of floating. So I added that GIF just to show that off.
Yes.
And that's the project.
Very cool.
Yeah.
All right, we have a question here from Connor.
Cow.
Yes,
I will add that YouTube video to the 3D page, and that video has an actual call out. You can pause, and it has all the calculations. And I'm glad I did the show today, because otherwise I may not have thought to add that. So after a show, I'll add that link in. And for folks.
Another thing, did you use a plugin in Fusion to generate the gear, to draw the gear for you?
Yes, there is a plugin I used. It's a native plugin. It's not like an extra thing.
Really? Okay.
Yeah. Cool. And in that tutorial, it goes through how you open it and how you like all the stuff you add in to get like the right number of teeth and everything like that.
It's a dialog box. And it's like, how many teeth?
Yeah.
What's the size of the module? How thick do you want your gear? So that helps you, so you don't have to draw the gear and do a pattern and all this stuff.
Right. Yeah.
Another tool that I like to recommend is oh crap, I forgot it. It's a website. Do you remember, like online gears or something?
It generates the SVGs. Yeah.
It's good to just kind of like
remember anymore.
Liz, you tried it out. But
I tried it.
Not working because it doesn't do planetary gears.
Well, yeah. So then there's a second version that would do planetary gears, but you would have to pay to be able to get the STL out, which, good if I was doing a lot of gears, I would have done that, but this was kind of a one-off, so I didn't. But that's also an option if you see yourself doing a lot of gears and you prefer that kind of style. Yeah.
Cool. All right. So Liz will add a link to the guide on that YouTube video. You sent it to me early too, because I wanted to look at it.
Right.
Because it takes the guesswork out of the gear. Like you could do a guesswork, which is what I've done, because I've only ever done 2 gears. But once you get into
all projects, remember having the chain go through. That one was all guessing.
It's all guessing. Yeah, but this one actually has a good an equation of how to get the right numbers. Cool. And there are also other gear generator tools, add-ons. I think I use GF gear or something because it lets you do helical gears too.
Right. Yeah.
But these are just like standard flat gears.
Right.
That you could laser cut or 3D print.
That's true. Yeah. You could even like CNC them.
You could print them out and cut them out of wood. If you need to.
Good point. Yeah.
A lot of options.
Options there. Very good. All right. Very good question, Connor. Thank you for that one.
Yeah.
And let's take a look at Discord. If anyone has any questions on the Discord.
Let's see.
A differential or something here.
Yeah.
That's cool.
That's cool.
Pedro put links to our GitHub repo for 3D models of Adafruit boards, like the KB2040, the NPM buck converter. What else? I think it's
the ST Spin 220.
Oh, and the ST Spin. Yeah. That's all there.
Yeah.
which is kind of like the same shape as the TMC 229.
Yeah, all the stepper motor drivers seem to have the same footprint, which is nice because we used a different stepper motor driver in the turntable project. But when I brought in the mount to my project and with the ST spin model, everything lined up, which was nice.
Yeah.
Beautiful.
Yeah.
Thanks to Lamar reusing
Yes.
out of, not laziness, but also like why create a whole new shape when it'll fit within this shape.
Yeah.
So I like that she does that.
Yep.
And Connor says thank you. No problem.
Of course. Yeah.
Thank you for the questions because we love to link other resources. All right. Well, let's spin your dreidels one last time before we move on to the next segment.
Put back in my gears here.
She's going to put the gears back in. Don't forget, support your maker habit. Support these creative folks with your orders. Dreidels is today's coupon code. It'll get you 10% off your order.
And we've got a Winnie kitty in the back by the tree.
Look at that! What a treat! A little bit of Christmas. We got some Hanukkah. Christmaka.
The smooth sounds of the gears is like ASMR.
Yeah.
Yeah. It sounds like a cat purring or something.
Yeah.
Yeah, I like it.
It's very satisfying.
Very satisfying. All right. Cool.
Yeah.
Did you want to talk about your menorah?
I can.
All
yeah.
Right. So as far as like
yeah, what are we working on?
Yeah, what are you prototyping?
Oh yeah. Okay. Let me get my orientations right. Okay, so my last project of the year is going to be a mag tag project. This is a mag tag in the case that you designed. And what it is going to be an IoT kind of virtual menorah. And what's doing is we have this menorah bitmap, and the actual bitmap actually has all the candles lit up. So it has all the flames. But what I'm doing is I'm using a little circular bitmap to cover them up. So they'll blend into the background. So there's actually circles that you can't see because they're white covering up these flames. And what I'm doing is I'm connecting to Wi-Fi with the ESP32 that's on here. It's getting the time from my Wi-Fi connection, and it's checking, is it during Hanukkah? It's because you have the date up at the top. When is Hanukkah? Which every year you have to look up. And
changes every year.
Changes every year because it's following Jewish calendar. But so it's first checking that, and if it's in there, it's counting how many days, so we know what night it is. But then it's also checking when is sunset, because it's at sunset you would light the next candle. And so if it's after sunset, and it will then light that many candles. If it's before sunset, though, it's going to only light up the number of candles. So tonight's going to be the fourth night of Hanukkah, if you've lost count. So right now we only have the 3 candles lit, and then at sunset, the mag tag is going to come back on, light up the 4th one, and then go into deep sleep. And then it's going to count the number of seconds till the next sunset, and it will come back on a deep sleep, light the thing. So that will be a nice quick project that will go live this week before we go on break. And you can use the case that we have in the shop, or you can print it yourself. And that way you can have a nice low maintenance way to track the 8 nights of Hanukkah.
Very cool. I don't think we've had something like this before, so
yeah,
this is nice.
I love how it checks all the parameters to light it up. It's awesome.
Yeah.
Thank you.
No API tokens needed, or yes?
No. To get the sunset, I'm using OpenMedio, which is an open source API for weather that you don't need an access key for.
That's awesome.
So it's just a quick HTTP request, and it's using your location through latitude and longitude just to see when your sunset is.
Right.
And we've used it before for other projects that have used sunset, like we did the star fragment lamp.
That's right.
And I want to say there was another project we did that involved sunrise that we used it for. So I really like that it has that parameter, and you can
this clock. One of the
Right,
the
yeah,
clocks.
one of the clocks.
One of the clocks. You've done a lot of clocks.
So many clocks.
And this is a clock.
It's
Essentially,
true.
it's a clock.
Technically,
Yeah.
yeah.
This is true.
Yeah. Some of the things I found interesting is that the way the candles are lit, it's actually from right to left and not left to right. And
And a lot of the code base is actually based on a project we did a couple years ago. We did a Christmas countdown that was a Christmas tree with baubles. Each of the baubles had the date for Christmas on December, and it would reveal the next date at midnight for the next day. And so I was actually able to reuse a lot of the code from that. Including the technique of the circles.
This was the orientation was portrait because
Yeah.
the Christmas tree was kind of like the graphic.
Mm-hmm.
It's kind of neat because it used grayscale a little bit.
Yes. Yeah.
That was kind of cool.
Yeah.
Yeah. MagTag's great. It's
It
in
is.
stock right now.
Yeah. We have the 2025 edition.
Yeah.
That has beaten the chip shortage
It has. Yeah.
and the
It won
tariffs
out.
and all of that.
Yeah.
And so
Very
definitely cool little board.
Very
And now we
crisp
have your
graphics.
case too.
That's right. Let's see if it's in stock. With the built-in kickstand.
Yes.
Appreciate
Been
everyone
using
buying them
it.
up because it has those snap-apart buttons that you put in the thing.
Mm-hmm.
What's great is it's
Fire
running.
switch.
It's all CircuitPython, so it's really easy to change the code depending on the season or whatever.
Yeah.
Cool.
Because normally we have it running. We have that fun weather project display.
Sorry.
That actually was updated to use OpenMedio because Open Weather Maps became kind of tricky with the API tokens. So yeah, OpenMedio, CircuitPython, MagTag for the win.
IoT ESP32. Very cool.
Yeah.
All right. Thank you for sharing that one.
Of course, yeah.
All right, we have 4 minutes left of the show. Liz,
Oh.
you just took over the show.
I just talked and
You
talked.
just
and
talked so
talked.
much. Well, appreciate you coming on.
Of
and
course,
sharing
yeah.
stuff.
Thanks
You
for
don't have
having
your own
me.
show, so that's good.
Yeah.
One thing, a comment from Taya saying the magnetic feet just came in stock back. Came
Ooh.
back in stock too. Yes,
Sweet.
great for magnetic sort of ferrous metal,
Yeah.
like
Yeah.
the fridge or
Fridge, or if you have like a
locker.
magnetic cabinet or pegboard, or
we have a magnetic door,
we do.
which you didn't know.
We do.
Great, very good, very good. Pedro, why don't you close us out with this week's
This
timeline?
week's community make last themed Christmas project for the year is this little funny light bulb buddy for a little Tealight. There's a bunch of these little swinging leg designs, and this one is like just a Christmas light bulb themed one. I think the funniest part about this one is his little butt here.
Wait, what? It has a butt. Hold
He has
on,
a
let's finish the video and then we'll go into the
actually, I should have talked about the Pet G.
the bulb itself. So not one color in terms of like the same, but two different colors.
Yeah.
Two separate models
Together.
Exactly, yeah. So yeah, it's just a nice little thing to add to your decorations with a little Tealight in there. You can barely see it though, but at dusk he definitely lights up.
I'm sure.
I like that it has the clip too, like the actual.
That's what I'm talking about.
Oh, okay. All right. Video's done. Let's take a look at the.
Let's take a look at his little butt. There you go.
Oh, it's a tail.
Yeah, it's just a little tail.
Yeah.
So it pops off, and then you can turn on your Tealight. It's so bright in here you can't see it.
Yeah. Okay.
Pops on, and
Is it
Okay,
twist
yeah.
to lock, or is it just like
no,
little-
it just has a little flames.
It's kind of-
Oh, man.
it
Super
kind
good.
of catches?
That's
Yeah,
cool.
It just catches.
Yeah. Okay.
Super simple.
Right. All right.
Didn't catch how long it took. Didn't take long at all. I had to rush up to stop the time lapse because it was pretty quick. But this is super cute.
It is cute.
That's cute.
Yeah. Yeah, I like the cartoony hands with the 4 fingers.
Yeah.
Okay.
There's some-
You didn't scale it up or down or anything, right?
Nope.
Just,
Standard. Just loaded 3MF from there and printed away.
All right. So this is a
Nice.
free design on makerworld.com. It's designed by, I believe, Evil Machinations is their name, I believe.
Mhm.
All right.
You may want to grab your own.
Oh,
The
our
coffee cup.
cat is
Attacking our Lego Christmas village.
yeah, kind of like her thing.
Yeah.
Let's see here. It's
Oh.
Christmas Light Buddy printed in PET. They also printed it in translucent PET G.
Yeah.
Okay. No special printing instructions.
Nope. The only thing I was suggesting, trying out the vase mode to get an even more translucent look to the bulb.
No.
They were just going for making it glow. I know. You okay?
Yeah, I'm fine. I'm just worried that she's gonna like jump into the sink because her kitchen's right over here.
Yeah.
Ah.
If she does, it's
Oh.
fine.
Oh,
It's okay. She's okay.
she's so
We're all
stealthy.
right.
All right, she's fine.
Yeah.
Yeah. So if you want to print your own, it's a free model. I mean, just
Cool.
look how cool their legs are. Look
Yeah.
how hip and
Just
chill.
chilling.
Just chill little
Chilling,
bulb,
bro.
a little bulb buddy.
Yeah.
Just bulbing. Cool.
Nice.
All right. No community makes other than the time lapse. So I think that's gonna do it for the show. I'm gonna check back into Discord and see if anyone has any final questions. Doesn't look like it.
That's it.
Over on the chats, everybody's good. All right.
All right.
That is gonna do it. Let's remind folks about the 10% off coupon code is Dreidels, plural, Dreidels, multiple Dreidels.
Mm-hmm.
Get you 10% off your order. Good for the next 24 hours. All right. For tonight, me and Pedro are on duty. We are going to host the show and tell tonight. That's right. We're doing a show and tell. I think it's the last one of the year.
I think so. Yeah. Because the holidays happen to fall on Wednesdays this year for Christmas Eve and New Year's Eve.
That's right. So 7:30 p.m. Eastern time is when it'll start. Come on by the Adafruit Discord server to get an invite link for StreamYard. You'll just click on that link if you want to share your project. No Ask an Engineer tonight. I just have this graphic because it used to be back-to-back shows, but Lamar and Phil are still on their maternity leave.
Mm-hmm.
And we hope they have a nice break.
Yeah.
Spending some quality time with the new baby.
Mm-hmm.
And their current baby. Double babies. All right. So that's tonight. And then next week, we don't have show and tell, but we have a special live unboxing with John Park.
That's tonight.
Oh,
I was going to say, I thought it was tonight.
it's tonight.
It's tonight.
Sorry.
Yeah.
At 8 p.m.?
8 p.m.?
8 p.m. tonight. I don't have a graphic. I just have John Park's Ada box. So JP will be doing the live unboxing.
Yeah, and you know JP, he always really puts on a good show. So
It's gonna be fun.
yeah, get some popcorn, prepare yourselves.
Yeah.
Yeah.
Thematical.
Take bets on what is the costume going to be.
Yeah.
Yeah.
And you know, if you haven't opened your Ada box, if you wait, you can do it right along with him.
Yep. Mm-hmm. That's right.
Perfect timing.
Yeah. Okay.
I think they've got this as a gift to themselves.
Yes.
Have earned it to open it up.
That's right. Connor was going to ask about the unboxing. There you
Yep.
go.
Tonight.
Tonight at 8 p.m.
Mm-hmm.
Eastern time.
Yes.
Don't know what GMT that is. All right, folks. It's been super fun having you on. It's very special when we have a special guest, Liz Clark, on.
Oh, thank you.
Special guest Liz Clark is signing off now.
Yeah. Thanks for having me. Thanks for letting me
problem.
talk about my
Anytime.
projects.
Yeah, it was a great one. All right, folks. We hope to see you tonight. And if not, we'll see you next year.
Yeah. Happy holidays.
Happy holidays.
Rest up, work on some projects.
Until then, remember to
Make
a
Great day.
year.
Make a great year. Oh, he changed it on us.
Thank you, guys.
Bye.
Okay, bye.